Hello world, my name is Israel. We begin with a circle and a plane and a point which is not coplanar with the circle, and we consider all lines passing through both the point and the circle. This generates a double cone. The point is called the apex, the circle is called the base. A straight line drawn from the apex to the center of the circle is called the axis of the cone. Either the axis is perpendicular to the base, or it is not. If the axis is perpendicular to the base, then the cone is called a right cone. Otherwise, the cone is called a scalene or oblique cone. A plane passing through both the apex and the base determines a triangle. Two of its sides are on the surface of the cone, by definition. One of its sides is a chord of the circle corresponding to the base. A topological structure, or more briefly a topology on a set X, is a structure given by a set D of subsets of X, having the following properties, called axioms of topological structures. 01. Every union of sets of D is a set of D. 02. Every finite intersection of sets of D is a set of D. The sets of D are called open sets of the topological structure defined by D on X. Let E be a set. A mapping F of the Cartesian product of E with itself into E is called a law of composition on E. The value f of xy of F for an ordered pair xy in the Cartesian product of E with itself is called the composition of x and y under this law. A set with a law of composition is called a magma. Some examples. If the set E is the collection of subsets of a given set, then both set union and set intersection are laws of composition. If we consider the Cartesian product of the natural numbers, the relations of addition, multiplication, and exponentiation are laws of composition. If we consider the collection of subsets of a given set, we can consider the composition of sets. In particular, we have composition of mappings. If we are given a lattice, then the relations of supremum and infimum, least upper bound and greatest lower bound, also form a law of composition. The first case, that of set union and set intersection, is a special case of this last example here.